Today we are talking about a new skill which is a browser skill, and it is integrated to the multi-agentic flow. So if you look at here, when a user query comes in, we do have the different skill execution where the planner the identifies what needs to be done as per the goal, and then the researcher would identify, let's say, if any browser action needs to be performed. And here we have the browser skill, which actually goes through the different browsing action to different approaches. And basically we have a four layer cost cascading approach, and it does the identification of the cheapest approach, and then the highest one. So, and this browser skill, what it helps is that as part of the first approach, it will extract through the basic HTTPX approach and the text extraction. If the specific URL provided by the researcher is not able and the browser is not able to do the extraction, then it will go to a more deterministic approach through a layer where we have a handwritten CSS selector and playwright approach, and the contents are being extracted. In the two, we have an additional B layer where we have a playwright accessibility tree, and extraction takes place through that approach with respect to the click events and all. If the things are not clickable, then we have a final layer, which is a vision approach. So basically, here we will take up a screenshot and set up the marks, numbered boxes, and all, and we will use a VLM in this case, which is a vision language model, and eventually extract the details from there. So the key points here is that if the, let's say, anything is blocked at a gateway level, for example, when we go to a browser and there are issues with respect to captcha and all in order to validate. So as of now we are not bypassing that, and we are validating whether those things are being uh, whether those things are being declined with respect to gateway blocking phenomenon. So in order to implement this, first we have a browser.md, which is the basic skill file, how the browser needs to execute, and then we have a skills file. Basically, the skill file is basically where we have defined the browser skill, right? And in this browser skill, we have implemented all the layering approach. Then we have a DOM file. Basically, in the DOM enumeration file, what we are doing is that we are identifying and we are converting the we are basically converting the uh, size. If let's say of a specific accessibility tree is 200 KB, or very high size 200, let's say x MB size page comes and rendered, we need to refine it and compress it to a few KB size. So those all being approaches are being done. If there are any JavaScript clickable events, then those things are being handled. Then we have a highlight file where we have, uh, let's say, if there is any, we are doing some kind of a screenshot, and if it is empty, so how those things are being handled, how the numbers are being handled, buttons are being handled in a screenshot especially, and ultimately it is being integrated to the final flow. Um, uh, and uh, uh, there basically the critics are being updated, so to handle it. And if let's say any browser skill failed, we have a mechanism for a retry, up to two retry. So now if we look at some of the queries as an example, let's say we have to compare couple of online AI courses under 1 lakh Indian rupees, and for each courses we need to extract few features, and based on that we need to identify the top course. So the planner will identify the goals, the researcher will identify the browsers which needs to be from where the URL, the URLs where the things need to be extracted. If anything which is blocked, for example, if the captcha is needed, it is blocked, it will try it and then eventually it will gracefully fail, and it will take go to the another URL to get the details. And finally, it will do the comparison. The critics will validate, and then we will have the in a formatter way. We are having the nodal summary and the final output, like which is course is being identified and why it is being recommended. Then we also have a cost estimator, because when we are not using the VLM, the cost, it is normally doing the internal uh, uh, Python packages. And if you look at the nodal approach, right, how the nodes are being created, if a node is being failed because of captcha, how well it is then um, defining the redefining the goal and extracting the details. If it is failing, we are getting a proper error, and that's how things are being handled here, and the final output is created. Let's look at a different query where we are we are not we are explicitly providing a URL where the person needs to identify the top rated books in the history section, and based on the rating and all, we need to identify the top book. So here it is directly going to the browser because URL is provided, so it can, we don't need the researcher here to identify the URL. It will directly go to the browser and will extract the relevant information, and it will take, and in this case if you see, it has taken few screenshots as well, where the screenshots are being sent, right, to the VLM, and ultimately it is extracting the detail and recommending the top three big books uh, based on the ratings. That's all for today. Hope you like the video.